11 men signed off on the well that killed them. Not one signature was forged. Not one check was skipped on paper. Every permit, every test, every sign-off that was supposed to stand between a drilling crew and a blowout was completed, initialed, and filed. And it still happened. This is the story of how a system built entirely around catching mistakes missed the biggest one of all, 49 miles off the coast of Louisiana on a rig called the Deepwater Horizon. The Horizon wasn't some rust bucket cutting corners because it was old or cheap. It was a Transocean-owned, ultra-deepwater semi-submersible built in 2001, capable of drilling in nearly 10,000 feet of water, one of the most advanced drilling rigs on the planet. It had a strong safety record. It had won safety awards. If you'd asked most people in the industry in early 2010 which rig was going to end up at the center of the worst oil spill in American history, the Horizon would not have made anyone's list. That's the first lesson buried in this disaster. Sophistication is not the same thing as safety, and a good track record is a lagging indicator, not a guarantee. The well it was drilling was called Macondo, in the Mississippi Canyon block of the Gulf of Mexico, under lease to BP, with Transocean supplying the rig and crew and Halliburton handling the cementing. Macondo had already been a difficult well before April 2010. Kicks, lost circulation, a stuck drill pipe that cost weeks of delay. The project was behind schedule by about 6 weeks and running roughly $60 million over budget. None of that by itself causes a blowout, but it sets the stage for every decision that follows, because every decision after that point gets made in the shadow of time and money pressure, and pressure has a way of narrowing what people are willing to see. The well design itself carried risk from the start. BP chose a long-string production casing design, running one continuous string of casing from the wellhead all the way to the bottom of the well, instead of a liner and tieback approach that industry engineers generally consider to have more redundant barriers against gas migration. The long string was cheaper and faster. It also depended almost entirely on a single, high-quality cement job at the bottom of the well to seal off the hydrocarbon zone. There was no backup barrier if that cement failed. One point of failure for the one job that absolutely could not fail. There were other shortcuts stacked on top of that single barrier design. Cementing engineers recommended using 21 centralizers, devices that keep the casing centered in the wellbore so cement can flow evenly around it. The rig crew had only 6 on hand, and rather than wait days for the rest to arrive, the well team proceeded with 6. Off-center casing means uneven cement coverage, which means more places for gas to find a channel through. It was one more small, defensible-sounding decision made under time pressure that quietly removed another layer of margin from a well that was already down to its last barrier.
And the cement job did fail. Halliburton slurry for the Macondo well used a foamed cement design. Nitrogen bubbles mixed into the cement to reduce its density for the specific pressures in that formation. Foamed cement is a legitimate technique, but it is also notoriously sensitive to contamination and mixing conditions, and later testing, including by the Federal Investigation Team, found that the specific slurry recipe used at Macondo was unstable in several of the lab tests run after the fact. In plain language, the barrier meant to plug the bottom of the well may never have properly set. Nobody on the rig could see that from the surface. The only way to know for certain the cement had sealed the well was to test it. That test is called a negative pressure test, and it's where the story turns from an engineering problem into a human one. A negative pressure test simulates the conditions after the rig temporarily disconnects from the well. You reduce pressure inside the drill pipe below the pressure of the formation and watch to see if anything flows back. If the well is truly sealed, nothing should come up. If it isn't sealed, fluid or gas will flow back, and that flow is the warning sign. On the night of April 20th, the crew ran that test more than once, and got results that did not look clean. Pressure kept building back up on the drill pipe when it shouldn't have. The crew and company men on site discussed it, compared readings from 2 different monitoring points on the rig, and ultimately accepted an explanation involving something called the bladder effect, a theory that pressure was being trapped in a hydraulic line rather than coming from the formation. It was the wrong explanation. The Presidential Commission that investigated the disaster later concluded the test results were not satisfactorily explained and should have been treated as a clear signal the well was not secure. Instead, the well team declared the test a success and moved forward with displacing heavy drilling mud out of the riser and replacing it with seawater, the final step before temporarily abandoning the well. That single misread on that single test removed the last barrier of fluid weight holding back a highly pressurized reservoir at almost the exact moment the cement itself may have already failed underneath it. What followed happened fast. As the mud was displaced, hydrocarbons that had begun leaking past the failed cement barrier accelerated their climb up the wellbore. Around 9:45 p.m., mud started spraying onto the rig floor, the clearest physical sign a well control event was underway. Crew members scrambled to shut in the well, but gas had already reached the rig by then, venting up through the derrick and into ventilation intakes for the engine rooms. At approximately 9:49 p.m., the gas ignited. A series of explosions tore through the rig, killing several crew members instantly and igniting a fire that would burn for more than a day. 11 men, Jason Anderson, Aaron Dale Burkeen, Donald Clark, Stephen Curtis, Gordon Jones, Roy Wyatt Kemp, Carl Kleppinger Jr., Blair Manuel, Dewey Rivette, Shane Roshto, and Adam Weiss died that night. 94 others escaped by lifeboat or by jumping into the Gulf, 17 of them injured. The Deepwater Horizon burned for 36 hours before it sank on the morning of April 22nd, taking the wellhead connection down with it and opening an uncontrolled path for oil straight from the reservoir into the Gulf of Mexico.
The blowout preventer, the 500-ton stack of valves sitting on the seafloor that exists for exactly this scenario, to physically crush and seal the well shut in an emergency, should have stopped this. It didn't. A forensic examination conducted for the federal government by Det Norske Veritas found that the blowout preventer's blind shear rams did activate, but a section of drill pipe had buckled off-center inside the wellbore at the critical moment, and the shear rams could not fully close around the buckled pipe to seal the well. A later, more detailed Chemical Safety Board investigation confirmed this pipe buckling failure mode and found it was a phenomenon the offshore drilling industry as a whole did not fully understand at the time, meaning the equipment that everyone trusted as the ultimate backstop had a failure mode nobody on the rig, or arguably in the industry, was prepared for. The well flowed uncontrolled for 87 days. Estimates of the total discharge eventually settled at close to 4.9 million barrels of oil, roughly 210 million gallons, making it the largest accidental marine oil spill in history, fouling shore mines from Louisiana to Florida, and devastating fishing and tourism economies across the Gulf Coast. It wasn't capped until mid-July and wasn't declared sealed until September. 3 major investigations picked apart what happened, and they largely agreed on the shape of the failure, even as they argued over the distribution of blame. BP's own internal investigation, released in September 2010, acknowledged failures in its well design and pressure test interpretation, but spread responsibility across Halliburton's cement job and Transocean's rig crew and equipment maintenance. The Joint Coast Guard and Federal Offshore Regulator investigation focused heavily on the blowout preventer's mechanical failure and equipment maintenance records. And the Presidential Commission, the National Commission on the BP Deepwater Horizon oil spill and offshore drilling, went furthest, concluding in January 2011 that the disaster was not the result of one rogue decision, but of systemic failures across BP, Halliburton, and Transocean, writing that many of the decisions that increased risk also happened to save those companies time and money, whether that was the intent or not. Their bottom line: this was avoidable, and without real reform, it would happen again somewhere else. Strip away the corporate names, and what you're left with is a permit to work and hazard verification failure that any offshore hand will recognize. A negative test gave an ambiguous result. Instead of stopping the job and escalating until the ambiguity was resolved, the crew found an explanation that let the work continue. That is the single most dangerous moment in any safety system. Not when there's no data, but when there's data nobody wants to be the one to act on. A JSA, a permit, a pressure test, a gas alarm, none of them protect anybody if the answer to an unclear reading is, let's assume it's fine, instead of, let's prove it's fine. Macondo had 11 separate opportunities across its short, troubled life where a stop work call could have changed the outcome. It only takes one.
The consequences didn't stop at the Gulf's waterline. The federal government imposed a 6-month deep-water drilling moratorium, idling dozens of rigs and thousands of jobs across the Gulf Coast, while regulators rewrote the rules for well design, cementing, and blowout preventer testing. The Minerals Management Service, the agency that had regulated offshore drilling and collected its royalties under one roof, a structural conflict of interest critics had flagged for years, was dissolved and split into separate bureaus for safety oversight and revenue collection. BP eventually pleaded guilty to 11 counts of felony manslaughter, 2 other criminal counts, and a felony count of lying to Congress, and total costs to the company for cleanup, fines, and settlements climbed past $65 billion in the years that followed, making Macondo not just the deadliest lesson in modern offshore history, but one of the most expensive. If you run maintenance, shift changes, or permit to work on any site, offshore, onshore, or industrial, download the JSA template built from real lessons like this one. Links in the description.